Hello, mathematicians. Welcome to day 2 of adding tenths and hundredths of fractions, lesson 25. So here we go. Now we're going to add and subtract fractions that have got denominators of tenths and hundredths. So warming up, write a fraction with a denominator of 100 that is equivalent to 2 tenths. Okay, you can push pause and give it a go. All right, welcome back. A fraction with a denominator of 100. So we want something 2 tenths is equivalent to something hundredths. And you know me, I'm a money person, so I'm thinking 2 dimes is equivalent to 20 pennies. If you're doing an equivalent fraction thinking, you're asking yourself, how does this 10 change to 100? You have to multiply by 10. If you do that to the denominator, you have to do it to the numerator, because then you're really multiplying by 1. And 10 divided by 10 is 1, which gets you to 20 hundredths. So that is our fraction. All right, that is pretty much the main idea of the week. Carmen has 4/10 of a dollar. Troy has 50 hundredths of a dollar. Together, what fraction of a dollar do they have? So first read is, what is this problem about? And it's about money. Parts of a dollar. Okay. Next, second read is, what are we trying to find out? Quick annotations, that's a little bit annoying. Okay. Oops, they're not saving yet. Sorry about that. Cancel. Carmen has 4/10 of a dollar. Troy has 50 hundredths of a dollar. Together, what fraction of a dollar do they have? So what information are we trying to find out? We are trying to find out what fraction of a dollar. So we're not really going to put it in decimals. Decimals, which is what we usually do with money because we want the answer as a fraction. All right. And then the third read, what information is important? Carmen has 4/10 of a dollar. Troy has 50 hundredths of a dollar. Together, what fraction do they have? So we got 4/10 for Carmen. And then let's put Troy in a different color. And then Troy has 50 hundredths of a dollar. It is important that it's of a dollar. All right, so Troy has 50 100ths for Troy. Carmen, might as well keep my color scheme going. Carmen has 4/10. And we need to add those. And we can't just add tenths and hundredths, we have to change that. Okay? We could change either way. So I bet you on the next page it's going to tell me to solve it. Yep. So on page 523, you can give it a go. If we were in classroom, I'd definitely say, show me with your base 10 blocks, do some kind of picture, but you give it a go with whatever way you can. Probably a picture, or you're using equivalent fraction style. I think I will change this 4/10 to hundredths, which means times 10 times 10. 4 dimes equals 40 pennies, 40 hundredths. Then I can easily add 40 hundredths plus 50 hundredths, because as we know, when you're adding fraction, you need the same denominator, which is the same size. Pennies plus pennies gives us 90 pennies, 90 cents. 90 hundredths is one of the answers, which could also be 9 dimes. So if you had 9/10, you are correct also, because that's 9 dimes or 90 pennies. Both are correct. So how did you do it? Did you do it in dimes? Did you do it in pennies? Did you do it in tenths? Did you do it in hundredths? Did you draw a picture? You could change it to decimals and then bring it back. That could be a way to do it. Compare some class strategies. All right, harder to do with this way, but let's see. If you were going to do decimals, 4/10 is 4 dimes, right? So 4 dimes would equal 0.4, 40 cents. And then if you were going to change 50 hundredths to 50 pennies, 50 pennies equals 50 cents. So then you could add it up, 90 cents. And to write 90 cents, two ways. You can write it as 90 hundredths, because see, we have hundredths placed there. Or you could just say 9/10, just for that place. So that's one way to do it. If you want to go straight to decimals and then bring it back to fractions, because it did want us to put it in fractions. But you could draw a picture too. Okay, you can use a picture to help you add fractions with denominators of 10 and 100. You know that 4/10 of a dollar is 4 dimes and 50/100ths of a dollar is 5 dimes. Okay, so they turned it all to dimes. Together they have 9 dimes. All right, that looks like a pretty easy picture. This is great if you've got these pictures drawn, harder to draw. You can use a model to help you add fractions with denominators of 10 and 100. So there's Carmen's 4/10, and then there's Troy 50/100ths, which is the same as a 5/10. Put it together in the picture, and you get 90/100ths. Cool beans. What are the denominators of the fraction you are adding? Are they the same? What are the denominators? Okay, so they are the same if you did, we did it more than one way. So if you do 4/10 plus 5/10, are they the same? Yes. So you can do it. You can change it to tenths. What are the denominators? They could be tenths or they could be hundredths. You can change it to thousands, but that would be weird. Complete the equation to use multiplication to find the fraction with the denominator of 100 that is equivalent to 4/10. Okay, so this is the same work that we did earlier. If you want it to get to hundredths, you have to go times 10 times 10, because 10 divided by 10 is still 1. That gives you 40/100ths. 40/100ths plus 50/100ths is still 90/100ths. Together, Carmen and Troy have what fraction of a dollar? 90/100ths. How can you explain how you can use equivalent fractions to add a fraction with a denominator of 100 to a fraction with a denominator of 10? So they're just explaining what we just did this. So here's our explanation right here. How can you use equivalent fractions? You change the tenths to hundredths, right? How do you do that? You multiply by 10 divided by 10 to get a denominator of 100. Yep, multiply by 1. That's how you do equivalent fractions. You multiply by 1. Look back at your try it strategies by classmates, picture it, and model it. Which models or strategies do you like best for adding fractions with denominators of 10 and 100? Okay, so do you like the picture it, where you can use like grids that have tenths and hundredths? And I'll try to add some of those to your, I will add some of those to the chart so you can print some of those out if you want to use that, because it does really help. That's why base 10 blocks really work well. Model it using the dimes or the pictures of the tenths and hundredths or the equivalent fraction strategy. I probably prefer the equivalent fraction strategy because it's pretty fast. So I would say, I guess I would explain with text first. The equivalent fraction strategy. It's a great strategy of just multiplying by 1. Okay, so that's where we did. You're going to put your example, 4/10 times 10. So that great strategy of multiplying by 1, depending on what you want it to go to. Beautiful strategy. Gazelle spends 7/10 of her money on a book and 10/100ths of her money on food. What fraction of her money does she spend in all? Show your work. Okay, so this is about Gazelle spending money. Second read, we try to find out what we want to find out. Gazelle spends 7/10 of her money on a book and 10 100ths of her money on food. What fraction of her money did she spend in all? So that's what we're trying to find out. All. So we're going to be adding important numbers. We have Gazelle spends 7/10 on a book, and then she spends 10 100ths on food. All right, so food is 10 100ths, which is a dime. Well, no, it's not a dime because we're not doing of a dollar. Ooh, I almost got tricked on that. You can't buy anything for 10 cents. Maybe a piece of gum. So 10 100ths of her money. We don't know how much money she has, but it doesn't matter because we're just doing what fraction of her money did she spend. Okay, so she spent 10% of her money on that. 70% of her money on a book. Must be a good book. Okay, so it doesn't matter how. Some people would think, oh no, we don't know how much money she has. That's okay. So this was the book. So to add these two together, I got to change one of them. I could divide by 10, divide by 10. Right? I could do that. Maybe I'll do that because we haven't done dividing yet. So if I change this to tenths, so I've got equivalent fraction strategy, but I'm changing it to tenths. 10 divided by 10 is 1. 100 divided by 10 is 10. So 1/10 of the money is on food, 7/10 on the book. So 7/10 plus 1/10 equals 8/10. So what fraction of her money? She spent 80% of her money. We don't know how much money she has, but again, it doesn't matter because what we're trying to find out is what fraction of her money. So 8/10 of money. Maybe she had $100. Maybe she had $10. We don't know. We do know you can't buy much with 10% of money. It has to be a pretty good pile. Next one. Show how to add 4/10 and 1900ths. Write the sum, show your work. Okay, so let's do this one. Let's change 4/10 to an equivalence of 100. So we multiply by 10, multiply by 10, because 10 divided by 10 is 1. So multiplying by 1 gives us an equivalent fraction. 10 times 10 is 100, 4 times 10 is 40. Okay, so now we can add 40 100ths plus 19 100ths. 40 plus 10 is 50 plus 9, 59 100ths. Okay, the showing of my work is showing how right here, how to get to equivalent strategy. Cool beans, cool beans. Number 9, Tucker is weeding his garden. The shaded model at the right represents the fraction of the garden that Tucker has already weeded. Tucker plans to weed 5/10 more of the garden before lunch. What fraction of the garden will Tucker have weeded before lunch? So we got 4 answers here, but I'm going to ignore that while we just solve it. So Tucker's weeding his garden. So the problem is about gardening. And it looks like this whole shape here represents his garden. That will be important. The shaded model at the right represents the fraction of the garden that Tucker has already weeded. Tucker plans to weed 5/10 more of the garden before lunch. What fraction of the garden will Tucker have weeded? So we're trying to find out what fraction of the garden, important, because this is the whole garden. So what fraction of the whole garden? Okay. And then the third read, we look for important numbers. Tucker's weeding his garden. The shaded model at the right represents the fraction of the garden that Tucker has already weeded. So this right here, already, that's an important number. And then 5/10 more. So we're going to be adding 5/10 to whatever this is. So this is a hundreds chart. So this is 1/10, 2/10, 3/10, and then, okay, so we got 10, 20, 33. So that's 33 hundredths. Okay, so 33 hundredths was already weeded. He wants to do 5/10 more of the garden. Be careful that it's more of the garden, not of what's left over. Okay, so 5/10 will change to, we know that 5/10, we change that to hundredths. We do times 10 times 10 is 50 hundredths. Okay, so if we do 33 hundredths plus 50 hundredths, we will get 50 plus 30 is 80 plus 3. 83 hundredths. Do we have that choice? Not that one. Not that one. Yes, that one. All right. So on your own, do pages 527 and 528. Please let me know if you have any questions and I will help you out. Have a wonderful day. Bye, mathematician.